Mr. Cobb, I don't get this. This is too hard.
Mr. Cobb, why won't you listen to me?
Come on, it's not that hard. It's just math.
Introducing the Dornettes, commonly known as Stanley. This is Stanna and Shanley, the hippest MCs in the calculus music industry.
This is the process for taking derivatives. First, you start with the function's exponent, reduce it by 1, move it to the front, multiply it out, and you're all done. For the chain rule, take dy dx of the outside, leave the inside alone. Take derivative of the inside velocity is the derivative of position. Dy dx of that is acceleration. Dy dx equals slope. If it's positive, it's increasing. Derivative is negative, then it's decreasing. Concavity is the second derivative. Concave up if it's positive, concave down if it's negative. When you're taking derivatives, you can make a sine table greater than or less than a point. If you're able, use the table to find. If you have maximums or minimums, then you can write an overall conclusion.
Mr. Cobb, this is too hard. This is too hard. This is too hard. Mr. Cobb, this is too hard. This is too hard. This is too hard.
It's not that hard. It's not that hard. It's just math. Value of f as x approaches c is the limit. Could be 0 or infinity. Continuity is defined when the limit as x approaches c equals f of c. Yeah, discontinuities can be present. Jump, removable, oscillating, infinite, intermediate value theorem. When f is continuous, f of c equals some value between f of a and b. It's just f is continuous. Mean value guarantees point c has the same slope as between a and b. Integrals represent area under the curve. They also demonstrate the antiderivative. The area under the curve of f is displacement. Initial plus the integral of f is position. Total distance traveled is the integral of absolute value of velocity, and that's all.
Mr. Cobb, this is too hard. This is too hard. This is too hard. Mr. Cobb, this is too hard. This is too hard. This is too hard.
It's not that hard. It's not that hard. It's just math. Derivative of sine is cosine x. Dy dx of tangent is secant squared. Negative sine is the derivative of cosine x dy dx of cotangent x is negative cosecant squared dy dx of secant is secant x tangent x. Theta cosecant is negative cosecant cotangent x dy dx of outline is 1 over x and derivative of e to the x is sometimes dy dx. Implicit differentiation, separating variables. Take the antiderivative plus c using integrals. Plug in the given point to find c. Plug in c and finish solving for y, and the unit circle from algebra 2 is useful for calculus, though it is review. Sine is the y value and cosine is the x. Tangent is sine over cosine, and you know the rest.
Mr. Cobb, this is too hard. This is too hard. This is too hard. Mr. Cobb, this is too hard. This is too hard. This is too hard. Calculus.
It's just
deactivating beast mode.
What does that have to do with calculus?
Absolutely nothing.
Nick Dorn's word rapping, that's right. Our AP Calc class, the unit circle of life.